Good morning, welcome to day 5 of our learning at home. So this is going to be your maths lesson today. Let me share my screen with you. Okay, so we are finished with coordinates. We are now moving on to decimals. So our learning objective for today will be decimals up to 2 decimal places. But before we do that, the time here is actually 10:38. Where are you all? I promised I'd play Rockstars with you, and no one's turned up. You're breaking my heart. I'm still waiting. If you turn up, I'll be there. So, our starter for today. We have some questions that you can try first. So I would like you to think about 342 divided by 10. If you were to divide 342 by 10, what would you get? What would happen to these digits if you were to divide it by 10? Pause the video and have a quick think. Okay, so hopefully you've remembered, whenever you divide by 10, the digits are all going to move to the right. So if I unshare and move over to a different screen, so hopefully you've remembered that they move to the right, which means because 10 has 1 0, those digits are all going to move one place to the right in our place value grid. So where we have a 2 in the ones column and a 4 in the tens column and a 3 in the hundreds column, they will all move one space to the right, which now means that we have a 2 in the tenths column, a 4 in the ones column, and a 3 in the tens column. And we also must remember to add in that decimal point. So 342 divided by 10 is 34.2. Pause the video and have a go at this one. Okay, so just like before, we are going to move those digits one place to the right because there is 1 0 and we are dividing by 10. So if we move those digits one place to the right, the 6 goes to the tenths column, the 8 goes to the ones column, and the 5 goes to the hundreds column. And again, make sure that we add in that decimal point, showing that 586 divided by 10 is 58.6. If you got that correct, well done. Right, so our lesson today is decimals up to 2 decimal places. So I would like you to have a think about these 3 questions. What fraction is represented on this bar model? Can you write it as a decimal? Complete the part-whole models. So these parts down here make up this whole number. And what is the value of the 6, the digit 6 in 36.48? So pause the video now and have a go at those questions. Okay, so the fraction that is represented on the bar model. Well, I can see that there are 10 squares. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And only 1, 2, 3, 4, 5, 6, 7 of these are shaded in, which tells me that as a fraction, we have 7 tenths. 7 tenths can be written as a decimal by dividing that 7 by 10, which would give us 0.7, because that digit 7 has moved one space to the right. For completing the part-whole models, 0.4 would need 0.6 to make one whole. 0.4 add 0.6 makes 1. For 0.2, we would need to have 0.8. 0.8 add 0.2 makes 1. And for our final question, what is the value of the 6? Ooh, the 6 is worth 6 ones because we have our tens column, our ones column, our tenths column, and our hundredths column. Okay, so here we have a tens frame. And if this tens frame was worth 1 in each space, we could say that 10 ones equals one lot of 10, because we have 10 ones here and they make one big group of 10. If we were to say that the frame is worth one whole, what would each square be worth? Have a think and pause the video now. Okay, so each square would be worth 0.1, because if you have 10 lots of 0.1, they would add up to 1. 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and then when you get to 0.9, if you add one more on, you will need to push that number into the ones column, because you can't have more than 9 in any column. It then needs to be transferred over to the next column. So 10 tenths is worth one whole. If the frame was worth 1/10, what would each square be worth? Pause the video and have a think. Right, so each square would be worth 0.01, because if we had 10 lots of 0.01, they would add up to 1/10, just like 10 lots of 0.1 added up to one whole in the previous question. So we would need each square to be worth 0.01 to be worth 1/10. So 0.01 is worth 100th, and we need 10 of those. Okay, we know that decimal numbers are part of a whole number. Like fractions, we know that decimal numbers are part of a whole number, just like fractions. We show decimal points with a decimal point like this. We show decimals with a decimal point like this to separate the whole numbers and the part numbers. Do you think you can fill in this sentence, which explains what we have here? There are how many ones, how many tenths, how many hundredths, and what the number is actually representing here. Pause the video and have a quick think. Okay, so I can see that there are no ones in here, which means we have 0 ones. In our tenths column, we have 3, 6, 7. So we have 7 tenths. In our hundredths column, I can see that we have 2 hundredths, which means we have 2 hundredths. So in total, we have 0 ones, 7 tenths, and 2 hundredths. So the number is 0.72. It is important to add that 0 point on here, otherwise we have 72, and that is a much larger number than 0.72. Pause the video and have another go at this question. Okay, so I can see that there are 3 ones. There is 1/10, and there are 3 hundredths. So the number represented here is 3.13. Okay, so have a look at these 3 numbers here. Can you write down what they would be in this sentence? Pause the video and have a go at that now. Okay, so for 2.05, we could easily say that there are 2 ones, there are 0 tenths, and there are 5 hundredths. So the number is 2.05. For 0.52, we have 0 ones, 5 tenths, and 2 hundredths. So our number is 0.52. This one can be quite tricky because we have the ones column and the tens column, but there's actually nothing in this sentence about tens. We only have the ones. Now that's because 57 is actually made up of 57 ones. But like I said, when you go over 9, you would have to transfer into the next column. So even though we have 5 tens, 7 ones, 0 tenths, and 6 hundredths, we can say that we have 57 ones. So this is 57 ones, 0 tenths, and 6 hundredths, and the number is 57.06. So, what is the value of the digit 5 in each of these numbers? Have a think and pause the video now. Okay, so in the first number, the value 5 matches with the hundredths column. So it's worth 5 hundredths, which is 0.05. In 57.06, the 5 matches the tens column. So that 5 tens is worth 50. And our final one, the 5 matches the tenths column. So that is worth 5 tenths, which is 0.5. So here we have 0.93. Here's our place value chart. We can see that the 9 goes in the tenths column, which shows that we have 9 lots of tenths. So in the hundredths column, we would need how many hundredths? 3. We have 3 hundredths in the hundredth column. This can be represented in a part-whole model. So we have 0.93. And to make 0.93, we can partition this number into separate pieces. We could have the 0.9, and then we could have 0.03. Because we have 3 in here, and we would have nothing in there and nothing in here, because we have partitioned it. We've taken those 9 tenths and we've put them over here, which means that this is now a 0, and we've put the rest of it over here. So here we have 2 different representations. Can you think of what is the same, what is different? What do you notice? Pause the video and have a think now. Okay, so if we partition these numbers, we can see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9 tenths. So we put 0.9 in here. And we have we have 3 hundredths. So we will put 0.03 in here, because it is 0 for our ones, 0 for our tenths, because we've already placed them in here, and then we have 3 hundredths, which shows that that representation is 0.93. If we move to the other place value grid, we have 1, 2, 3, 4, 5, 6, 7, 8 tenths in our tenths column, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 in our hundredths column. So we have 0.8 for our tenths and 0.13 for our hundredths. Now, I said earlier in this grid that it would be 0.03 for this over here, because we'd moved the tenths out. So you might be wondering why there is a 1 in the tenths column down here. Now that's because, like I said earlier in the video, you can only have 9 in this column, and 9 in this column, and 9 in this column. If it adds up to 9, everything's fine. But if it adds up to more, send it next door. So we have 13 in here, which is too many. So we can take 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them, and those 10 will need to be transferred into the tenths column because 10 lots of hundredths make 1/10, which means we now have 9 in this column, and it would leave us with 3 left over. So we have 0.13 as we have moved 10 lots of these hundredths into our tenths column. You should now also be able to see that 0.8 added to 0.13 equals 0.93. So they're actually representing the exact same number. It's just the fact that this side has got the 10 in this column, which has already been transferred into this column over here. Right, so here we have a turtle. I think he looks like a Fred. Fred says that 7 ones and 2 hundredths is 7.2 as a decimal. What do you think? Do you think that Fred is correct, or do you think Fred may have made a mistake? Pause the video and have a think now. Here is our place value grid again. We have 7 ones, which Fred has said here. So we've placed those 7 ones in our place value chart. He also says that we have 2 hundredths. So they will go in this hundredths column over here. There we go. Now I can see that there is a space in here. We can't leave a space without a digit in it if it is between any other digits. We can ignore it if it's over here because that's just a place value holder, and we could ignore it if it's on the end because it's another place value holder. However, if it is in between, it is relevant and we have to include it. So it actually represents 7.02. Unfortunately, Fred did make a mistake. Whitney has 4 cards. She has a 1-digit, a 5-digit, a 2-digit, and a 3-digit. She needs to place them all in the boxes below. What's the largest number Whitney can make? What's the smallest number Whitney can make? And how many different numbers can Whitney make altogether? You can pause the video and have a go at these. Now, I'm going to give you a hint. With this last question, how many different numbers can Whitney make? My hint is going to be that there is actually over 20 numbers. So have a think about how many numbers she could make and pause the video now. Right then. The largest number Whitney can make is 5, 3, 2, 1. To work out what the largest number she could make is, you always take the largest digit first and place it in the column furthest to the left. In this case, the 10th column. 10th, that's wrong, the tens column, because we want the largest amount in the highest value column, and tens is bigger than ones, tens is bigger than tenths, and tens is bigger than hundredths. So you want to have the biggest digit over here and then work your way down to the smallest one to show that largest number. So when we're showing the smallest number Whitney can make, we would do the opposite. We would have the largest number in the hundredths column and then the smallest number in the tenths column. So we've put the 5 in the hundredths, the 3 in the tenths, we've put the 2 in the ones, and the 1 in the tenths, which leaves us with 12.35. Okay, so how many different numbers can Whitney make? We can work them out systematically. So I'm going to start with 12.35. I can then change the 3 and the 5 around to give me 12.53. I could then do 13.25. And I will change the 2 5 around to give me 13.52. I'm then going to start with 15.23. And I can again change the 2, 3 round to get 15.32. So here we have 6 numbers already, and that is always starting with 1 as our first digit. So we had 1, 2, 3, 5, 1, 2, 5, 3, 1, 3, 2, 5, 1, 3, 5, 2, 1, 5, 2, 3, 1, 5, 3, 2. So this time we'll start with the 5 as our first digit. So I have 5, 1, 2, 3. Now I can change these digits around and I'll get 5, 1, 3, 2. I will then start with 5, 2, 1, 3. And then I can change them around to get 5, 2, 3, 1. I will then use 5, 3, 1, 2, and then change these around to get 5, 3, 2, 1. You can see here that I'm also using the lowest digit going to the, I'm using, you can also see here that I'm ascending in my digits. So I'm going higher as we go down. So this time we will start with the 2. Okay, so it is now time to do your worksheets. Let me show you those. So this is worksheet 1 for today, and this is worksheet 2. All of these questions should be able to be answered without having to print out the sheet. So if you can't print them out, you can just write down the question numbers and then write the answers next to them and send that to the email address. That will be absolutely fine. Once you have completed these sheets, if you wish to, now this is optional, it is always optional, you can have a go at the challenge sheets. So let me show you those. We have challenge 1, which looks like this. So if you feel like having a challenge after those 2 worksheets, you can complete these. There is also challenge 2, which looks like this, which is slightly trickier than challenge 1. Now, today we actually have a challenge 3 as well. So if you think that you have managed to do all of this work really easy and you have flown through it with super ease and you want an extra challenge to challenge your brain, you could complete challenge 3. Now, challenge 3 is tricky because unlike having all these digits easily in the correct columns, we have questions like 504 hundredths. Now we can't put 504 in the hundredths column. So you're going to have to think about where 504 would be represented on a place value chart. Okay, now I will also place a place value chart in the area where you can download these worksheets so that you can use them if you need to. So remember, the challenge sheets are optional. You are not expected to complete all of them. You have the choice of doing those. That is up to you. Have fun with your maths, and I will see you in the literacy video. Bye.